Hi, welcome to this video. It is Leetcode 203, remove linked list elements. So for this particular problem, what you have to do is that you're given a linked list and they are saying if there's a value of 6 that you see when you go through it, they want you to return the linked list where every time you see that 6, it's removed. So you see here, they want to get rid of 6, and in the end, it's 1, 2, 3, 4, 5, because they remove the 6 here, and they remove the 6 at the end. This, of course, falls under the technique of linked list, because it's already in the problem. Previously, we looked at removing, reversing a linked list, where it helped to have like a previous pointer or variable, and the idea is very similar here, as we shall see. So let's take a look really fast. Now, really quick refresher for the average developer. A linked list is basically where you have a node, and the node points to another node. And hopefully at the end, it gets all the way to null, and there are no cycles, okay? Sometimes you have linked lists with cycles. Those are different kind of problems. And we did a video on that before. But today we're just going over this problem, which is an easy problem rated by Leetcode. So what do you need to think about when you look at this kind of problem? Well, what happens when the goal of the problem is to remove 3 and they give you a linked list of just 3s? So 3 points to 3, points to 3, points to null. Well, that's one scenario, right? In which case you would just return null. Okay, so you know that in your final solution, before you really start working on a linked list, you have to get rid of any of the target values that are at the beginning, at the head of the list. Okay, when I first started thinking about this problem, I was trying to combine removing 3s from the start and doing the rest of the problem because I thought that's what a clever solution would be. You don't have to be clever. I think it's important to just get to the solution. When you're in an interview, think of what you need to do in different steps. So part of our algorithm is that we need to solve for the edge case of when there are plenty of 3s at the beginning. Okay? That's something that we just have to know. That's part of our final solution. Now, once you get 3s in the beginning, you can start to process the rest of the list. So here I changed the target to 30, a 2-digit number, so it's easier to see. So one part of your solution will be to say, get rid of all the targets at the front. Okay, then you process the list. Then you process the list, you go 1, 2, get rid of this 30, get rid of the 30 at the end, and this 3 will just point to null. Okay? And that's what you have at the bottom. That's your solution. And we're going to run through the code really fast and you see exactly how this works. First, let's bring up the code. This portion of the code in JavaScript, as usual, is only talking about the part after you have gotten rid of the target values at the front. So there could have been other values of 30 in the front, but we got rid of them already. And now we're on to the rest. And the rest is making some assumptions, right? It's assuming that, hey, you know, rest of this is not null, because if it's null, you just skipped all the way to the bottom and you just return null, basically. So you don't have to worry about that. So let's take a look at what variables you want to keep track of. Of course, you want to keep track of current and right neighbor. In reversing a linked list, you obviously wanted a previous because the linked list, if you're imagining it, would go from pointing to the right into pointing to the left. So that's why having a previous works there. But in this case, you don't need previous. What you want is the current and you want to know what's to the right of current. Very often you see people name that as next. I find that to be very confusing because inside of these linked list nodes, they have the next value. So I don't want to get too confusing, so I name it right neighbor. You'll see a lot of developers who have naming conventions that are shorter, but I think while you're learning, for the average developer, name your variables long and descriptive so you know what you're doing. Okay, in step 1 of this while loop, what we're going to do is, if the right neighbor has the value to skip, well, first the right neighbor has to exist, right? Exist is not null. Does it have the value to skip here? No, it doesn't. So we come to this line. So current equals right neighbor. So you're going to move current over to the right, and then right neighbor is going to move to the right also. Okay? And what is that going to look like at the next step? Well, at the next step, that's going to look like this. So once again, you are going to come to this line, right? Well, first, right neighbor is not null, so we continue. And then we check the value of right neighbor. Well, the value of right neighbor is 30. Target value is 30. So we do what's inside the if statement. So current.next equals right neighbor.next. So what you would do is you basically point your arrow here. That's what's happening programmatically. And then you go to right neighbor equals right neighbor.next because you have to move this guy right here. You have to shift him over to the right. So what does that look like at the next step? Well, the next step is what we just talked about, right? So right neighbor shifted to the right, and now right neighbor is 3. So right neighbor is not null. We continue. Check the value of right neighbor. Well, we don't do this line. We'll go to the else. So current becomes right neighbor. That means this guy right here shifts all the way here, and then right neighbor itself shifts to right one spot. Let's see what we get when we do that. What you get when you do that is this, okay? Again, right neighbor exists, but then you check the value of right neighbor here at this line. Well, it actually equals our target of 30, right? You see right neighbor equals 30. And what you want to do is current.next should point to right neighbor.next. So once again, current.next, instead of point at 30, points to right neighbor.next, which I forgot to write, but obviously this value is null. And that's going to be your solution, right? It's going to end up being 1, points to 2, points to 3, points to null. That will be your final solution. It's pretty straightforward. I think when you think about this problem, just try to focus on doing what you know and the different steps that you need. So of course the first step is early exit. If it doesn't exist, get rid of it. And then you skip ahead. This is part 1, right? And this is part 2. So as long as you remember to keep these things separate and not try to get too fancy and tricky and do them together, you will come up with a solution. And that's it for Leetcode 203, remove linked list elements. Thank you.